The pH of salt solutions. When you dissolve a salt, for example, sodium chloride, if you dissolve a salt like sodium chloride in water, what will the pH of the solution be? Well, wait a minute. We know all salts are ionic compounds, aren't they? Yes, they are. All salts are ionic compounds. And we also know that when ionic compounds are dissolved in water, in the case of sodium chloride, it will break into sodium ion and chloride ion. All ionic compounds, when they're dissolved in water, they break up into ions. In this case, we'll have sodium ion and chloride ion. Well, that doesn't make sense. Why do we have to worry about the pH of its solution? Aren't the pH supposed to be 7? Because we know that hydronium ions are related to the pH of our solution. Hydroxide ions are related to the pH of our solution. Hydronium ion will make a solution more acidic. Hydroxide ion will make a solution more basic. However, sodium ion, chloride ion, they're not hydroxide ion, they are not hydronium ions. Why do they have an impact to the pH? Well, they may, depending on what ions we're talking about. Ions may have an impact to the pH of our solution. Therefore, we need to talk about the pH of salt solutions. So, let's move on. When salts are dissolved in water, they break up into ions. However, those ions can behave as acids or bases. Why? Because some of those ions can react with water. And not only they react with water, they may produce either hydronium ion or hydroxide ion. Therefore, they will have an impact to the pH of a solution. This kind of reaction, something reacts with water to produce hydroxide ion or hydronium ion, is called a hydrolysis reaction. To summarize it, some ions generated from a salt, when you dissolve a salt in water, it will generate ions. Some of those ions may react with water to produce hydronium ion or hydroxide ion, therefore, to make the solution acidic or basic. Does that make sense to you? Then how do we know if it will generate hydronium ion or hydroxide ion? In the next few slides, we will look at different kinds of salts. We are going to classify all salts into different categories. Depending on which category a salt belongs, it may make the solution acidic, basic, or neutral. So let's move on. Types of salt and the pH of their solutions. We are going to ignore the hydrolysis part. That part will not be tested. It is not required for this class. Throughout this semester, I always emphasize that you need to understand the concept. Try not to just simply memorize it. Make sure you understand that. Well, this is one of those situations that I do not emphasize understanding, because you only need the conclusion for this class. All right, so there are actually 4 kinds of salts. The first is the salt of a strong acid and a strong base. What are we talking about? What does that mean by saying the salt of a strong acid is a strong base? Do you remember that when we were talking about neutralization, we concluded that all salts can be considered as children from an acid and a base parent? Do you remember that? When an acid reacts with a base, it always produces a salt and water. So we have practiced a lot like this. Given a salt, for example, NaCl, we practiced how to get the acid and the base required to prepare the salt. How to get the acid and base parents of a salt formula. Do you still remember how to do that? All right. To get the acid, you take the negative ion in the salt. You keep adding proton to it until it is neutral. In this case, HCl. That will be the acid parent of this NaCl, sodium chloride. To get the base parent, you take the positive ion, you keep adding hydroxide to it till it is neutral. That will be the base parent, NaOH in this case. So, hydrochloric acid and sodium hydroxide are the acid and base required to prepare that salt from neutralization reaction. HCl is a strong acid. How do you know it is a strong acid? Because it is one of the 7 strong acids. Sodium hydroxide is a strong base. Again, how do you know it is a strong base? Because it is a hydroxide from column number 1A and 2A metal. All right. Therefore, NaCl is considered a salt from a strong acid and a strong base. Category number 1. If the salt is from a strong acid and a strong base, the solution will be neutral. The pH will be around 7. If you dissolve this kind of salt, a salt from a strong acid and strong base, the solution will be neutral. The pH will be around 7. Some other examples. KCl, it is from HCl and KOH, a strong acid and a strong base. Sodium nitrate from nitric acid and sodium hydroxide, strong acid, strong base. The solution will be neutral. All right, let's move on. The second category is the salt of a strong acid and a weak base. For this kind of salt, the solution of this kind of salt will be acidic. Not too hard to memorize, at least. Strong acid, weak base will make the solution acidic. Couple examples here. Ammonium chloride, the acid is HCl, the base is ammonia. Remember, we talked about this when we were talking about the salt specifically. We talk about this base. You can claim it is from ammonia, or you can claim it from ammonium hydroxide. Okay. When you dissolve ammonia in water, you're going to generate this. Either way, but ammonia here. Ammonium is the most common weak base you will encounter in this class. So this is ammonium chloride is a salt from a strong acid and a weak base. If you dissolve ammonium chloride in water, the solution will be acidic. The pH will be lower than 7. Okay, the equation here talks about why, the reasoning, hydrolysis. Don't worry about it. It is not required for this class. The third kind of salt is a salt from a weak acid and a strong base. Well, weak acid, strong base. No surprise, the solution will be basic. pH will be greater than 7. Example, sodium fluoride, hydrofluoric acid is a weak acid, sodium hydroxide is a strong base. Potassium acetate, acetic acid, a weak acid, potassium hydroxide, a strong base. All right, if you dissolve either one of these in water, the solution will have a pH greater than 7. The solution is basic. Again, don't worry about this. Number 4, the salt from a weak acid and a weak base. Good news for us. We cannot decide if the solution of this kind of salt will be acidic, basic, or neutral. In order to do that, we need more information about the weak acid and the weak base. We need to know which one is even weaker in terms of acidity or basicity. Therefore, I said it's good news because if we need more information, it cannot be decided. It will not be tested. All right, some more examples here. Okay, if the salt is from strong acid, strong base, solution will be neutral, pH will be around 7. Couple examples here, okay? And some other examples here. Predict. What do you expect the pH of solution formed when each of the following salts is dissolved in water? Greater than 7, around 7, or lower than 7? Okay, I'm going to do the last one with you, and later on you do the first two. So again, in order to do that, we need to know from what acid and what base this salt is prepared. So to figure out the acid parent, you need to take the negative ion, keep adding protons to it till it is neutral. No, I'm sorry. The charge of carbonate is too negative. So take the negative ion, keep adding protons to it until it is neutral. It is going to be H2CO3 because carbonate carries 2 negative charges. Proton has only 1 positive. You need 2 protons. It is a weak acid. Weak acid. To get the base, you take the positive ion, you keep adding hydroxide to it till it is neutral, and NaOH is a strong base. A salt from a weak acid strong base in solution will be basic. The pH will be greater than 7. That's the answer for this one, for number 3. All right, you can pause the video, do the first and the second one, then unpause the video to check the answer key. Here is the answer key. See you next time.